Let's get stuck right in because I know it's the end of the day, so I assume we have in the audience all the people that are most eager to learn how to help their applications or their companies save the most money in running their CI/CD pipelines with Spot instances. So my name's Boyd McGeechy. I'm a member of the EC2 Compute Business Development team, and I focus specifically on Spot instances. So today, the presentation we're going to go through is going to be focused on how you can run your Jenkins pipeline with Spot instances. And so really that's broken up into two main sections. One where we'll spend sort of the first half of the presentation making sure you understand the ins and outs of Spot. And it would help explain why we're going to do a couple of things when we do get to the demo, about why we make these recommendations and why we suggest following these certain best practices. Did anyone attend the presentation by my colleague Derek earlier today? Okay, so there is going to be a small amount of repeat, unfortunately, but there's only a very small portion of you in the room. So apologies, and we will get into a demo in the second half. Let's jump in. So first and foremost, Spot instances obviously help you save money. We're going to try and focus most of the demo and most of our conversation on CI/CD. But obviously, there are many other workloads that you can use Spot. And the fact that you're here at a DevOps conference and that you're using tools like Jenkins actually suggests that there's a good chance that a lot of the applications you run probably could take advantage of Spot because of the nature of those applications. So just a few examples, actually Lyft. Lyft is an example that adopted Spot first for Jenkins. A funny story, it took me about 2 years trying to convince them to make these changes. They didn't believe it was going to work or they didn't have the time to make the changes. And then finally, my general manager was friends with one of the people running the system. Turns out it took 4 lines of code and less than an hour on a Saturday. And Lyft was able to reduce the cost of their Jenkins build servers by 75% adopting Spot. Yelp is actually another customer who uses Jenkins as part of an overall continuous execution engine. And so they've presented at reInvent a few times. I won't go into it too deep here, but effectively this is a container platform that's automatically driven when builds are pushed to Jenkins, and then they're automatically executed as well. So a fully automated pipeline. And again, for them, it was a matter of actually accelerating the pace at which they could analyze and get results. And then finally, Illumina, we won't spend too long there, but if any of you are running large-scale grid workloads that are fault-tolerant, which almost all grid workloads are, it's a great fit for Spot. You can save a lot of money. And what you'll learn for the next 10 minutes will actually help inform how you would apply Spot in those applications as well. So hopefully, hopefully you can save money with any Jenkins servers you're running at the end of this, but obviously look how you can apply Spot more broadly. A few of you did attend Derek's presentation, so you probably know this. Is everyone here an AWS customer or have used it in some way, shape or form and know EC2? I assume most of you. So obviously we have 3 main business models. I'm not here to tell you Spot's going to apply to all of them, but what I am here to tell you is if you can use Spot, and for centralized Jenkins pipelines, it's certainly a very common workload, you can save a lot of money, up to 90%. Customers generally see about a 70-75% discount on average when using Spot instances. And you can almost get those same savings with reserved instances, but there's no commitments for Spot, right? You pay by the second. When you don't want it anymore, give it back to us and you stop getting charged. So great if you have dynamic, bursty workloads or elastic workloads like this might be. That's weird. So why Spot instances? Probably from the title of the presentation, the main reason people want to use Spot is because it's cheap, low predictable prices. But also just make sure as you're adopting and thinking about Spot, are there things that, sometimes we work with customers that say, well, hey, I have a set budget. And so potentially by adopting Spot, we might not be trying to save money, but we're actually trying to give our developers access to 5 times as much capacity because of these savings. And so Spot, sure, save money, great way to think about it, but also make sure you're thinking about whether you could be using this to deliver faster results if you have a fixed budget and that's constrained how you operate in the past. And then finally, hopefully you'll agree through the demo that it's a pretty easy to use Spot following best practices these days, but something for everyone to be aware of, particularly any long-term AWS users here. We have invested heavily in the last 3 years to make it way easy to use Spot. So if you're launching EC2 these days, if you want to use Spot, it's normally 1 parameter in whatever you're using to provision a Spot instance. You don't necessarily need to learn new APIs. If you're using autoscaling, great, you can keep using it. If you're using run instances, great, you can keep using it. So we have invested a lot there, and you should continue to expect us to invest to make it easier and see more and more integrations, again, like the demo we'll do at the end here. So hopefully it sounds cool, it sounds exciting. What are the rules or what are the things you need to consider when you are using Spot? So first and foremost, Spot is exactly the same as the other types of EC2, right? If anyone's ever said to you, oh, I don't know about using Spot because there might be a performance difference, no, that's not a thing. While the instance is up and running, it is identical in every way, shape, and form as an on-demand or a reserved instance. Spot is literally unused on-demand capacity. That is what it is. So it's exactly the same. Security, performance, all of those things are exactly the same, obviously. The difference is we can take it back off you because of spare capacity. I've already mentioned the savings. Diversify. And so this is where we're going to spend a bit of time here today, because diversifying is the way that customers are able to successfully and regularly use Spot for production, mission critical, even revenue generating applications. Instance diversity is the key to be successful with Spot. So we'll spend a bit of time on this. And it's something that, for the largest part, I want to work with customers that are designing scalable, fault-tolerant applications, right? Then the work to adopt Spot, it's not necessarily that much more. The one thing we're going to ask you to do that's a little bit different is diversify instances. One last point, obviously, you'll hear me talking about the interruptions, the fact we can take capacity off you. It's really, really important to understand that while we talk about it all the time, because it is the caveat, it is the downside of Spot, over 95% of the time, customers actually finish their work and turn off their Spot instances themselves, right? So just to put it in perspective, to use Spot, you need to be able to re-queue a job, right? If you're running a test or a build and the server is taken off you, it would obviously not be a great experience if that test didn't go back to the queue and get reprocessed. However, don't confuse the fact you need to be prepared for interruptions with this idea that it's going to happen all the time. It doesn't happen that often. You just need to be prepared for it. I've already mentioned the fact that if you're designing fault-tolerant, scalable applications, adopting Spot is just about being instance flexible. So that's a really big point there. And then finally, the 2-minute warning. So we'll talk a little bit about different ways to use this. But really, it depends on the nature of the application. It depends even how you've designed your Jenkins architecture, potentially, on what you're going to do with that 2-minute warning. There's 2 main ways we see customers using the 2-minute warning. And I'll give you a third, which people often think is how they use the 2-minute warning a lot. So first and foremost, if you're running a system behind a load balancer, customers use the 2-minute warning to detach the server from the load balancer and say, hey, I'm about to go away. Don't send any more jobs my way. Any jobs that are currently running can be gracefully drained if they can finish within that 2-minute warning, but just use it to disconnect and say, hey, I'm going away. When we're connected to a scheduler, which again is a very common pattern that you're going to see a lot with Spot, it's a similar concept. It might be, instead of saying to the load balancer, disconnect me, you're just saying to the scheduler, hey, again, I'm going to go away. These jobs that are currently running, you might want to put them back in the queue. Most schedulers these days will work it out eventually, but you might use that 2 minutes to get them back in the queue faster and just say, hey, these jobs are canceled, they're not going to work. And then finally, the third one that people think they're going to use it a lot, but it really doesn't happen that often, to be honest, is to try and checkpoint or save the state of the application. If you can save the state of the application in 2 minutes, great. Reality is it's not that common that we see customers able to finish and fully save the state of a system in that 2-minute warning. So, don't necessarily think that's going to be the cure-all here. So this is hopefully what you're going to feel like if we can adopt Spot successfully. And so let's start talking about what I mean by diversify and how Spot capacity is made available to you so that when I start talking about best practices later, it makes sense. So we have a lot of spare capacity naturally, right? In order to deliver the elasticity that's in the name EC2, right? It's what the E stands for. We need to have spare capacity available. Otherwise, when you try and launch an on-demand instance, we'll say, sorry, we don't have that, we can't, right? And so while we're talking about Spot being our spare capacity, we have a great deal of it if you're willing to be instance flexible. Because what I can tell you all is we have never run out of Spot capacity. It has never happened, not in a single availability zone, in a single around the world. It's never happened. We do run out of a very specific instance type in a very specific availability zone of a very specific size every day, somewhere around the world. And so I just like this sort of slide to help put it in perspective because we talk about spare. This is actually Clemson University. This is about 3 years ago now, so it's a little bit old. Our spare capacity has only gotten bigger in that time. But they were to scale to over 1 million concurrent vCPUs on spot in a single region without telling us. I worked with them on the architecture because the schedulers kept failing, but we did nothing in terms of getting spare capacity and making it available. The reason they were able to achieve this is because they were willing to use 12 different instances. They used 4XLs and 8XLs from a bunch of different families. And so, they got 500,000 from here, another 200,000 from there. And so that's why instance diversity is so powerful, because our spare capacity is sort of, unfortunately or naturally, locked up in these different capacity pools that we make available. Jump over that one. So I have this Tetra slide to sort of hopefully visualize that and sort of explain that concept, right? That all of these are completely different instance types, and if you've been tracking AWS has been growing and EC2 has been growing, you're probably well aware that we keep launching new instance types, we keep launching new sizes, and all of those are independent capacity pools. So let's talk about this specifically and then we'll move on. So what does it mean to be flexible? Every instance size is completely independent. So if you say, is the M4 extra large capacity different from the M4 large capacity in US East 1 availability zone A? Yes, they are separate capacity pools. So when I'm talking about instance flexibility, it doesn't necessarily mean T2s and X1s. It could just be M4 larges and M4 extra larges. Instance families, this one is pretty obvious. Hopefully everyone can work this one straight out, that M5 and M4 have completely different chipsets. So they're obviously different capacity pools as well. So maybe if you're using the M4 extra large now, you could also consider using the M5 extra large as well. It's just newer, more powerful, more recent, and that's a way that you can be instance flexible. And then finally, availability zone. So I almost never suggest to a customer to go multi-region to use Spot. It's almost never a good idea. It's almost never necessary to actually do that to be successful. Unless you want to run a workload that needs over 1 million concurrent vCPUs. And if you do want to do that, please come chat with me at the end because I'd love to talk to you about it and see what we can do. But most applications don't need that type of capacity or anywhere near it. So what we do encourage though is every region does have multiple availability zones. So the US West 2 region here has 4 availability zones. That means if you can use, let's say, 2 different sizes and 2 different families, so M4XL, M4 large, M5XL, M5 large, and 4 availability zones, you actually end up with 16 separate capacity pools that you are using. And so again, this is going to play into the best practices and how we're able to use Spot successfully with Jenkins and the demo that we're about to show you. The whole idea is one of those 16 pools, we might run out of capacity. The chance of us running out of capacity in all 16 capacity pools approaches 0. I can't say 0 because it is non-zero, but I can say in the 5 years I've been working in this business, it's never happened. So it's very unlikely. Now let's quickly cover off one other thing. Again, this is something that people that have been using Spot for a while or might maybe have tried it in the past, it's a really important point. In 2017, we fundamentally changed the way the Spot pricing model works, okay? So there's no such thing as bidding anymore. What you have the option to do is set a max price. So you can say, I don't want to pay for a server if it's any more expensive than $1, as an example. But every Spot customer that has an instance running in the same capacity pool is paying the same price, right? Because you actually pay the going rate. So even if you say, I'm willing to pay up to $1, if the current market rate is 10 cents, you pay 10 cents. I would encourage all of you to forget the concept of max price and just not even worry about it. If you don't submit a max price, we just automatically set it to on-demand and ensure you never get charged more than the on-demand price. It is not worth thinking about bids. It is not worth thinking about max price. All of that has largely gone away. It doesn't help you hold on to servers. When we need a server back from you, it's because we need it for on-demand customers, and we're going to come and take it off you. Doesn't matter what your max price is. Now, as I said, 95% of the time people finish their jobs and turn the servers off themselves, but just forget max price and bid price, please. If there's one thing you remember as you walk out of this, if you think about bidding with Spot, you're thinking about it the wrong way. You're thinking about it in a prior in a mode how it worked before 2017. I've been talking about the average interruption rate. You might wonder, hey, I run my Jenkins server right now on a C4 large. What was my chance of being interrupted and how much would I have saved over the last month? We have a public web page that you can go and actually look that information up. So you can go and see for what instance types, what was the chance of interruption, and what would you have saved over the on-demand price. It's called the Spot Instance Advisor. If you Google that, it will be the first result. So go check that out to help hopefully convince you that I'm not up here selling you snake oil.
Are interruptions more common during peak business hours when presumably we would also need the most amount of spot instances?
Are interruptions more common during peak business hours when we would need more instances? Yeah, they are, of course. If you can run at night or on the weekend, your interruption rate is going to go even lower than those numbers we're talking about. But if you think about it, I was talking about the public average rates, that 95% number. And it is true that most customers use more spot instances during the business day when they're at work. And so those numbers I'm talking about are actually representative of what you just asked, right? If you can run on the weekend, yeah, it's awesome. Don't really work with many customers that do that, unfortunately. Many people aren't willing to time shift their workload so that they can reduce interruptions. And so instead, what we do is we use that instance flexibility. And we'll talk about a new feature we actually launched just on Monday this week that helps you automatically, from those 16 options I just talked about, we can automatically put you in the pool that has the most capacity. And so during peak, maybe 5 of those 16 have gotten worse. Our system can just automatically avoid those 5 and pick from the remaining 11. So I just want to talk about 2 tools, 2 different tools that really help drive spot best practices in how you use them. So I've been talking about instance diversity. Some of you might be sitting there thinking, oh wow, how many scripts am I going to have to write so that I can pick from these 16 different instances and make sure I'm picking the cheapest and the most available. You don't need to do that. We have fully automated that process on your behalf using 2 different APIs. Well, actually 3, unfortunately, but really only 2. So the first 2 is Spot Fleet and EC2 Fleet. These are pretty much the same API. They've just got different names because we added on-demand to it, and some customers thought it was weird to use an API called Spot Fleet to only launch on-demand instances. So for all intents and purposes, just think about these as the same API, right? What EC2 Fleet and Spot Fleet do for you is let you define multiple different instance types, and then you pass what's called an allocation strategy. And that's what we were just talking about there, actually. So you can say, here's 16 different options, automatically pick the cheapest for me, or automatically pick the one that has the most capacity available. Then, if we do take those servers off you, we'll send you a 2-minute warning. We might only take, let's say, 10% of the servers that you've got running off you. And the Fleet APIs will go, oh, I've lost some of my capacity. Let's automatically replace that rapidly, right? And so you lose some from this capacity pool, and the system automatically relaunches spot instances from another capacity pool. And that is why I sort of make that point that that's how you can run this consistently for production or revenue generating applications. Because even if you've designed a fault tolerant application, you'd probably all legitimately say to me, yeah, like I can handle a server coming and going, but I can't handle not having capacity, or I can't handle losing all of my capacity at once. And that's what these APIs automate on your behalf. You give us the instances and the zones that work for you, and then we automatically pick them. Now, it's actually a very similar story with autoscaling these days. This is relatively new. It came out at the end of last year. So how many of you run your Jenkins servers inside of autoscaling groups? Great. So the demo I'm going to show you is using a plugin. The best practices you'll use, but I'd actually suggest you keep using autoscaling groups and use the functionality that I'm just about to talk about. Right. So prior, again, to November 2018, if you wanted to follow Spot best practices, and put in the M5 large and the M4 large into a single autoscaling group, it wasn't possible, right? You needed to go out and create 2 autoscaling groups and then try and work out how to communicate between the 2 groups to make sure that you always had capacity, whether it was cheap or not. And so it was relatively difficult. And in fact, If This Then That, who's a startup, hopefully some of you are aware of, that's been using Spot for many years now, used to have 37 autoscaling groups so that they could follow Spot best practices. Now, It's just a single group, right? So now you can have a single auto-scaling group that combines on-demand, RI, and spot, and that you can put multiple different instance types into that auto-scaling group as well. And then those allocation strategies I was talking about, like pick the cheapest or pick the capacity pools that have the most capacity right now, all of those are also available through this auto-scaling group system now, okay? So we'll show you the demo, I'll explain that. It's a plugin that we actually own and maintain ourselves to connect Jenkins with the Spot Fleet APIs. But if you're currently running your Jenkins workloads in an auto-scaling group, just go flip it to Spot, right? And follow this auto-scaling mixed instance policy best practices. Just very quickly, figured we'd, I mentioned at the start there are multiple different workloads. The demo obviously that I'm going to do is going to be focused on Jenkins. But these are sort of the 4 workloads that we see customers adopt Spot and be the most successful with the least amount of work, right? So big data, if you're using EMR or Qbol or Databricks, they all have phenomenal Spot support and all have an ability to follow our best practices. CI/CD, obviously, we'll talk about that. Web services. This is a bit of an interesting one. A lot of people would think that Spot is really great for batch jobs and asynchronous tasks, and it is. It is really good for that too. But what we found was, with modern web applications, because people have designed them to be fault tolerant and scalable and stateless, that a lot of customers are actually able to migrate large portions of their web servers onto Spot. Because if you think about it, how many of you wait more than a minute for a website to load these days without thinking something's wrong with your internet? If you're like me, you start unplugging it and trying to work out what's going on. And so that 2-minute warning is a lifetime when it comes to running a web service. So again, it just comes back to that point that I was talking about earlier. What we find customers running scalable stateless web services, they don't care about servers coming and going. They need to make sure that there's always enough capacity to serve the next web user, right? Whoever else comes to their web app. And so there's a bunch of customers that have been doing this really successfully for a long time. I don't know whether this is a good thing or a bad thing, but if you see an ad on the internet, there's a really good chance it comes from a Spot instance, because that's a very cost-sensitive market. So a cool one to talk about, cool one to be aware of, that you can run even a website on Spot. And Mercado Libre, who is a large e-commerce company in Latin America, presented with me at reInvent last year about how they do this as well. So if you wanted to learn more, you could check that out. High performance computing, that's where most people think about Spot being ideal. If a job fails, you just restart it and rerun it. And if you can save money, great. How many of you are using containers already? Yeah, okay, that's almost as many hands as using AWS. So containers are obviously becoming increasingly prevalent, increasingly common. And people are adopting them obviously for developer productivity, ease of use, these types of things. But there is that other core sort of concept of a container, which is the whole point is you can run it here, you can run it there, you can run it anywhere, right? And so we're seeing a lot of customers using containerized workloads on Spot because instance flexibility comes out of the box, right? You tell it how many cores and how much memory it needs, and you don't necessarily care whether it runs on a high memory box or a CPU box, as long as it has the resources. You might not care, you might not even be aware, right? So on top of that, oftentimes people are running modern applications with containers as well. Don't want to spend too long on this because I think we've already spoken about the core use cases for the discussion today. But obviously in each of those categories, we have a bunch of customer references and stories. These are on our website, and often for all of these as well, we have templates, CloudFormation templates, or compute blogs that sort of guide you step by step on how to do this the right way. All right, with that, I want to jump into a demo of how we could plug a Spot fleet following best practices into an existing Jenkins deployment. So normally I would just use a CloudFormation template, but that makes for a really boring demo. And so we're going to go through and click through it sort of step by step. And feel free to throw questions at me because there will be some waiting as we go through, and I'll repeat them and we can chat about that as well. Alrighty, so I did a little bit of work before I arrived, just making sure I had my Jenkins server up and running so that we didn't need to wait too long. This is vanilla, just the sort of standard recommended plugins and installs on the way in, so I haven't really done any of the work yet. And as I say, because normally I use a CloudFormation template, I have my little cheat sheet here to make sure we do all the steps the right way. This also, we'll publish this and we'll share on YouTube with the team. We have a step-by-step guide on GitHub. So if you're missing steps, don't freak out, don't worry about it. This is step-by-step. Or if you want to do it the fast way, we also have that CloudFormation template available on GitHub to just automate all of this on your behalf as well. The difference is the CloudFormation template assumes you haven't already stood up your Jenkins infrastructure. Alrighty. So the first thing I'm going to do is actually jump over to the AWS console and create a user. So I'm going to create a user so that I can provide access to the Jenkins master to control and scale my resources inside of the AWS account, okay? Because I don't think we'll be able to get to it today, but something that we can actually automate with this plugin as well is scaling your Jenkins nodes, your slaves up and down dynamically based on the actual jobs in the queue. And so this role gives the Jenkins master permission to do all of that work. So we're just going to call it the Jenkins IAM profile. Because obviously we're going to be accessing it programmatically, we need to turn on programmatic access. And now I'm just going to attach these two different policies, spot fleet tagging role, correct. And then I'm going to go and get the EC2 read only as well. Attach both of those. I would obviously recommend normally using tags. I'm going to skip that here today. So you can see I've got these two managed policies that I'm connecting to this IAM user. And again, this is giving it really two main controls. One is the ability to control the spot fleet, to scale it up and down dynamically as the Jenkins master decides what it needs to do and how much resources it wants. And the other one's just giving it access to read EC2 resources and get that information that it requires. So let's create it. And now this is a very important point. Do not lose these. These are very secret. I'm sure you're all very much aware. But if you do not get them the first time, you will never see them again. So make sure you get your access ID and your secret key, or you won't have a good day. All right. Now with that done, we've saved them both in our doc here. Obviously, you can download the CSV if that's what you prefer as well. Now we're going to go and do really the main piece of the best practices here. And as I mentioned, we've been investing quite heavily in making this easier and just automatically following best practices on your behalf. And so come to spot requests. I'm going to say request a spot instance. I'm going to try and keep the instances relatively similar sized. The reason I want to keep them similar sized is your Jenkins jobs might not be able to dynamically take advantage of extra resources, right? Particularly if you're not using containers in how you deploy those jobs. And so instead of potentially ending up with a box with 32 cores and a box with 2 cores and just underutilizing the bigger box, we're going to keep it nice and even. If you're using ECS, EKS, or any type of containerized management here, then you could probably be more flexible with different sized instances as well. But we don't need to worry about that here. Because we're trying to encourage people to be instance flexible, we actually added this option in the console to just provide specs instead of instance types, right? And so we can set the specs to, anyone know what the standard size instance they use for their Jenkins builds? C5.9 extra large, that's too big. All right, I'm gonna go for, I don't know, let's just go for an extra large, given I've been yapping along about that so much. It's too big, I don't want the C5.9s. So that's going to automatically, actually I'll talk about that later, we'll see it later on. This is going to automatically go and look at selecting instances that have a good price and a relatively low chance of interruption from that tool that we shared earlier and automatically select them. We'll see them in a moment. As I mentioned, we want to be as flexible as we can be. Okay, so I'm going to select 3 availability zones, 3 different subnets, because as I mentioned earlier, that means I'm tripling the amount of capacity I could get access to that I can launch. You don't need to do this, but I do recommend it. This is a really important point. Make sure that you're saving your key pairs as well. You're being intelligent about that. And then for this plugin to work properly, we need to make sure that we're providing a security group that the Jenkins master can SSH into, right? So whether that means setting it to the security group to a security group or an IP, whatever it may be. I'm cheating here because we're doing a demo and just making an SSH open to the world. Obviously, we don't recommend that. And I'm going to automatically attach a public IP as well. When we built the plugin originally, that didn't have a lot of this functionality, or it wasn't as easy to use. You can now actually run all of this using private IPs, so you wouldn't need to do this. But for simplicity today, I'm just going to throw some public IPs on all of these worker nodes that we launch for Jenkins. And then finally, probably most of you are aware of this, obviously, but we need to get the latest version of Java, or at least 8, up and running. So I'm just going to put these bash scripts in so that we can make sure that we install the correct software and bring the right tools so that it can connect to the Jenkins master. And then we should probably provide some tags. Call it the Jenkins worker. Now, I'm going to click maintain capacity, right? And this is the point I was making earlier. By clicking maintain capacity, if an instance is taken off you, Fleet is going to automatically attach that back again, right? That's sort of the whole point. So by clicking maintain, you can turn on auto scaling. But even if you're not auto scaling, even if you just set I want 100 workers all the time, by clicking this box, if any spot instances are taken off you, Fleet is going to replace them from a different capacity pool in a matter of minutes. And so here's what I was talking about earlier. It's actually provided a set of instances that it recommends that are a good price and relatively low chance of interruption. I actually don't like the T3A because I have a feeling my image is not going to work with that chipset. So I'm going to select a different instance because I don't trust it. Bring in a C3 large to my group there instead. And then the Fleet allocation. So here's what I was talking about where you can pass what strategy do you want it to follow. Okay, so we've passed it these 3 different instance types here. We've passed it 3 different availability zones. So the allocation strategy is how you tell Fleet what matters to you. How should we decide from all of those options where to deploy your instances? I recommend using the capacity optimized. Particularly as you're getting started, if you're running on demand today, capacity optimized is probably going to save you 70%. And because it's automatically picking capacity pools with a lot of instances, you're not going to see that many Jenkins jobs fail, right? You could go to the lowest price mode, and that might save you an extra 1 or 2%, but it might cause your interruptions to be higher. Okay, so I recommend doing the capacity optimized when you get started. I recommend lowest price mode for what I call the bottom feeders. And I say that very lovingly. People that have very, very short jobs that don't mind being interrupted, because a little secret for you all, if you get interrupted in the first hour, it's free. And so some customers that have 1-minute jobs really love getting interrupted 50 minutes into their first hour because they get 49 jobs done for free. Now, I won't spend a lot of time helping you do that, but that's when you should be using lowest price, when you sort of fall into that category. Otherwise, I highly recommend capacity optimized. And with that, you can actually see the projected savings versus running these as on demand. Pretty good savings. And so I'm going to launch that. And then I'm going to store this ID. Again, you don't really need to worry about losing this one. Unlike the secret keys, this one will not disappear. You will always be able to get it back again, but we'll keep it simple here. All right, now let's jump into Jenkins, just to check I'm still loaded. So this is the plugin that I mentioned that we offer. Again, if you're already running with auto-scaling groups, I would suggest just changing your auto-scaling group's configuration. But this is really for those of you who are either just getting started with Jenkins or you're running using on-demand, calling run instances today, or using a different plugin. Come check this out. So let's go to the plugin manager. I'm going to go to available. Oh. Yep. And then I'm going to type EC2 Fleet. Remember what I said earlier, EC2 Fleet, Spot Fleet, same thing. Don't worry about the difference. This is actually connecting to a Spot Fleet, as we just saw, even though it's called EC2 Fleet. Don't let that scare you. Now, here is the biggest chance of this demo going wrong. So let's all hope that the demo gods are nice to us here. I want to restart this when we're done. Go for it.
So when you're talking about thinking what strategy, you talked about the lowest and the capacity, the middle one for diverse. When do you that?
So diversified is good for web services. Okay? And actually the way diversified now works, you tell us how many instances, how many capacity pools you want us to diversify across. So it used to be we'd just use all of them. So you gave us 16 pools, we'd try and use all 16. Now you can actually say, hey, pick the 6 cheapest options and diversify across them. The reason that's powerful for a web service, right, is that it's relatively low chance that we'll take all of your instances off you at the same time, even if you're in a single capacity pool, but it could happen, right? It could theoretically, a whole bunch of customers come in and they destroy that entire capacity pool. And if you're running a web service, now your website's down or your service is down. And so the diversified mode ensures that you're across more than one capacity pool, so that the most you could lose, for example, would be half of your capacity if you're using 2 pools. Or if you're using 10 pools, you might, at worst case, lose 10% at the same time. And so that's when diversified is really powerful. Say CloudFormation or config? Fargate. That's a sort of, there's no connection there, I suppose. So this is vanilla EC2, so if you're running your Jenkins jobs on EC2, if you're using Fargate, that's sort of the different model that you've gone, the serverless model, obviously. Yeah. I am on the guest Wi-Fi. I do have a backup, by the way. I have one that we baked earlier. I just hope we don't have to go to it. It's actually looking good, even though it shouldn't have.
I think it restarted and never refreshed.
Ah, yeah. He knows.
It's famous.
Just get impatient and reload.
That's what I had been doing. I thought I was doing it the amateur way. If anyone's worried, I don't personally maintain this plugin. Much smarter people do it. Should take a few seconds here. While we're waiting for that, why don't we go check out our active fleet? And so we can see it's decided to launch one instance because that's all we requested. And it picked the C3 extra large. Okay, so that probably is more expensive than the T3s, but because we put them in as equal and said just pick whichever one has the most capacity available, it's gone and selected the C3 extra large, actually, is what I put in. Alrighty, so that's a good sign. We see the EC2 fleet status down here. So what I'm going to do now is manage Jenkins. We should get there in the next 8 minutes, I think. Alrighty, so I'm going to scroll all the way down to the bottom and say add a new cloud. And as you can see, despite the fact we've called it EC2 Fleet, it's now called Spot Fleet. Please don't let that freak you out too much. And so I'm going to add some credentials because I don't have any. And remember, this is the ones that I mentioned earlier that give the master the ability to control the fleet. That's what I'm giving it access to right now. So I'm going to go to Kind, change it to AWS credentials, and then you can see the access key and secret key. So let's go copy that from earlier. All right, then we'll add that. And then I launched this in US West 2, the Oregon region. And we're going to say show all fleets. And of course, you should actually select the credentials you've provided it. That's an important step. Now we can see some fleets. All right, so what's the fleet that we actually created? It ends in CD. Well, that was nice. All right, I'm just going to quickly check the connection. Success, that sounds good. As I mentioned, we're going to launch the agents via SSH, so make sure that's the one that's selected. And now we're going to pass it the ability to actually SSH in, so the PEM key. Username is EC2 user, and I'm going to enter this directly. That, and we'll select that credential, and then we're going to select the non-verifying verification strategy, which I love the name of, and then hit save. And what we hope to see, fantastic. So it's now connected. It's now got the ability to automatically schedule jobs on this extra executor that we have here. We won't have time, unfortunately. Obviously, we've only got 5 minutes left here. Now you can see the resources actually being brought up because the fleet successfully launched it and it's registered. And so now we have the ability to automatically submit jobs, and Jenkins will put them on the spot instances that Fleet is launching. We don't have time today, but again, in the GitHub profile that we have, the next step would be to set up the ability to automatically scale as well. So that's built in. We just haven't really turned it on. There's not a lot of extra steps. But instead of that, let's just create an item. See that this thing actually works. I'll just do something really simple here. Save that. And then we'll build it a few times. And again, just as an example, I'm going to come in here and kill this spot instance. We probably obviously won't have the 2-minute warning, but I'm going to come in here, and what will automatically happen, again, unfortunately we won't have time because we'll just run out here, but if I came in and actually killed these spot instances that have been launched on behalf, those jobs that have been submitted will just go back into the queue and wait for another instance to come up unless they can actually run on the little instance that we already have running there. So if I'd killed this, it could cause an issue for those jobs if they weren't so short. But as I say, Fleet is now going to automatically recognize that this instance is being killed and go back and relaunch another one to make sure that we're maintaining capacity for your Jenkins servers. And what I was going to say is this is an architecture of the version of the CloudFormation template that we'll share after this will actually build for you. Let's see, I think this has a couple of builds. And so the CloudFormation template goes a little bit further and actually routes all of the jobs through a load balancer so that we can automatically find the instances that have the most available capacity. That can sometimes happen if you don't add that extra layer, that it'll stupidly keep trying to schedule it on a box that it thinks has just enough resources, but it doesn't. So the load balancer automates that process of finding where the most idle capacity is right now. And that's all we have time for. So obviously hang around and keep answering any questions that you might have. Feel free to come up or shout them out, whatever you'd like. And yeah, really appreciate you hanging around until the end of the day.